Hi, today we're going to be talking about your assignment, the dilation worksheet. This assignment has multiple parts, so we're going to do an example and we're going to take each part one at a time. So the first one says, dilate each figure by the given dilation factor k. To do this, multiply each coordinate by k. Draw the new points and connect any lines. So our pre-image for this dilation is the triangle that you see on your screen. So, and we are dilating this by a factor of 4. That's why we have the rule at the top. XY becomes 4x, 4y. So if we take the point 1, 1, and we multiply each of those by 4, our new point will be 4, 4. 2, 3, 4. 1, 2, 3, 4. So that will be this point right here. If we take our point 3, 1 and we multiply both of those coordinates by 4, we end up with the point 12, 4. 6, 7, 8, 9, 10, 11, 12 to the right. 1, 2, 3, 4 up. So our new point will be the point 12, 4, or for our image. Okay. Our last point is 2, 3. So we're going to multiply each of those by 4, and we'll end up with the point 8, 12. 1, 2, 3, 4, 5, 6, 7, 8 to the right, and 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 up. Will get us the point 8, 12. And then it says to connect any lines. So I'm going to use my line segment tool here in OneNote. Make this a little bit neater. So our new triangle is the red triangle. That's step 1. Step 2, for each point in its dilated image, draw a line through them. What do you notice about where these lines meet? So now I'm going to draw a line. For 1, 1 and 4, 4. So we're going to go 1, 4, 4, 1, 1, and keep going. There. Wait, I was going to do that a different color, make it easier. Okay, try again. So 4, 4, and 1, 1 were the pre-image and image points that coordinate. I'm drawing a line for those. Then the point 8, 3, 8, 12 was the image of the point 2, 3. So I'm going to draw those. And then 12, 4 started out as 3, 1. So where do all 3 of these connect? All 3 connect, all 3 of these lines connect at the origin. That is because the origin, or the point 0, 0, is our center of dilation. Number 3, measure the original perimeter and the perimeter of the image. Find the ratio of the perimeters. So our perimeter is the distance around. So I need a new color that I haven't used yet. How about purple? Okay, so when we look at our original image, pre-image, with 1131 and 13, we're looking for the distance around. So from 11 to 31, that is 2. So that's pretty easy calculated. But this goes diagonal. But we got our good friend, Pythagorean theorem, that will help us figure that out. So we have 1 squared plus 2 squared, and then we do the square root of that. So using my handy dandy calculator, I'm going to do square root of 5. And we get 2.236, which I'm going to round to 2.24. So the distance there, the distance right there is 2.24. Finally, I need to figure out what this side is. And we find that it's the same situation. We have 2 squared plus 1 squared, and then the square root of that. So this side is also 2.24. Now to find the perimeter, we just need to find the perimeter, we just need to add those up. So 2 plus 2.24 plus 2. Hold on. 2 plus 2.24 plus 2.24 is 6.48. So the perimeter of the original pre-image is 6.48 units. Okay, so we also need to find the perimeter of the big triangle, and then we are ready to find the ratio of the perimeters. So on this one, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 across the bottom. And if we use our Pythagorean theorem friend, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8 also. And over here, we're going up 8 also. That won't always be the case that it'll be symmetrical like that. So it may be that you've got 3 different side lengths totally. 1, 2, 3, 4. Over here is 1, 2, 3, 4. Okay. So 8 squared plus 4 squared equals 980. And then the square root of that is 8.94. So this is 8.94. This over here is also 8.94. So this side and this side have a length of 8.94 plus the 8. So the perimeter of the bigger figure is 25. Okay, clear. 8 plus 8.94 plus 8.94 is 25.88. And it says to find the ratio of those. So we're going to do big figure to little figure. So if you do 25.88 compared to 6.48, you will find 3.99999. So it approximately has a ratio of 4. So our perimeter seems to have increased fourfold. Lastly, it says, for the last set of instructions, for closed figure, do the same for the area of the original and its image. It says, hint, use the grid to break it down so you can find the area. So here we have, in this smaller figure, we've got 2 right triangles. Need yet another color so we won't get confused. How about this bright blue? So if I divide this right down through here, I have 2 right triangles that are 2 and 1. So you find the area of a triangle by doing 1/2 base times height. So 1/2 the base, which is 1, times the height, which is 2, is going to be an area of 1. So that has an area of 1 and that has an area of 1. So the area for the pre-image is going to be 2 square units. The area for the image, similarly, so I can break this triangle down again into smaller triangles that I can do the area of using 1/2 base times height. If I create right triangles, my base and height are the sides, which is nice. So here we've got 4 on the bottom and 8. So 1/2 of 4 times 8 is 16. Same thing over here. So that area is 32. So if I do my ratio of 32 as my ending to 2, our ratio has increased by 16. How does 16 relate to the number 4? As you continue to do these 4 problems, I want you to look for what is happening with the perimeter and the area compared to the scale factor you are using. For example, here we're using a scale factor of 4. So our perimeter ended up being 4 times as much. The area ended up being 4 times 4 as much when we dilated it. And then how does that change, if at all, when we are shrinking instead of getting larger? So that's what you're going to think about, and you're going to have a Padlet post that you are going to do. We're going to share those thoughts with one another.